Good morning. This is Mr. Somerville and Marjorie's dog Scout. Say hi, Scout. Okay, don't say hi, Scout. So I was having coffee with Marjorie this morning and checking the news and said atmosphere found around Earth-like planet for the first time. That's the news. So I was trying to explain this to Marjorie because we've now detected thousands of exoplanets. Those are planets around, you gotta hush. Planets around other stars, but this is the first time we've ever been able to tell what's in that atmosphere. So I was trying to explain to Marjorie, how do you tell what's in an atmosphere? If you remember me explaining this to you in class, one of the ways that we can find a planet around another star is we watch the star very closely and it gets a little bit dimmer. That's because the planet is going in front of the star. It's an eclipse. And if the star gets a little bit dimmer, and then exactly 9 months later, it gets a little bit dimmer again, and then 9 months later, it gets a little dimmer again, we know we got something going around in front of the star. It's got to be big enough to make a faraway star get dimmer. It's a planet. So when the planet goes in front of the star, we know it's there because of the dimness. But now for the first time, what they've done is they've been able to take a peek at what's in the atmosphere. The question is, how do they do that? So the way they do that is by looking carefully at the light that comes from the star. Normally, when a star is burning, it puts out a very distinctive pattern of light from that particular star. And this gets us into something called spectroscopy. You know, most stars are just made up of hydrogen and helium. That's the vast majority of what stars are. And the hydrogen is a very simple atom. It's just got one proton and a little electron whizzing around it. The thing about any atom is that the electron that whizzes around it can be at what's called its lowest energy state. That's called the ground state. Or it can be more excited. It can be at the first state, or the second state, or the third state. The thing that has made so much of modern astronomy possible is when an excited electron stops being excited and goes from being excited down to ground state, the electron falls from one state to the other. And when it falls, it lets off one photon. That photon always has exactly the same wavelength. The best way to explain this is like a guitar. If I tune a guitar string and pluck it, bong, it'll make exactly one sound. If I change the tuning, it'll make a different sound, bong. And what you have to understand is every element, hydrogen, helium, lithium, boron, all of them have exactly their own sounds. Actually, they play chords because there's more than one electron in the atom. Except for hydrogen, it's only got one electron. But all the others have several electrons. And when the electrons fall from their different states, they make this sound bong, or this sound bong, or this sound bong. And when you play them together, I can't do this with my mouth, you get a chord, boom, just like playing a guitar. So when you look at the star and you see the light coming from the star, you hear the hydrogen chord, boom, and the helium chord, boom, and the lithium chord, boom, and that's it. But when this planet passed in front of the star, all of a sudden, the light added new chords. And in this case, the chords were methane, which methane is not an atom. Methane is a molecule. It's got one carbon and 4 hydrogens, and that makes an even more complicated chord. So we get the methane spectroscope showing up. We get the methane chord playing. And we also get water vapor. So what we know about this planet is that it seems to have water and methane. What we also know about it is it's about 1.3 times as heavy as Earth. We can tell that by the way that the star wobbles. And we apparently can tell how hot the planet is. And you think about methane, that's a greenhouse gas, and water vapor, that's a greenhouse gas. You put those two greenhouse gases together in one planet, and guess what? The planet apparently has a temperature of about 450 degrees. So not where you want to visit and start your new space colony. Okay, first planet with an atmosphere, how we know it. See you guys later. Bye.